Welcome back to Remathable. Today we're diving into one of the easier but very important topics, functions. Functions have always been a part of the syllabus, but with domain, range, and composite functions added recently, we want to make sure nothing is left untouched. So here's how we'll break it down. First, we're going to introduce functions and learn how to substitute values to find specific answers. Then we'll cover how to determine domain and range based on the question. After that, we'll move on to finding the inverse of a function, which, trust me, is actually simpler than it sounds. And finally, we'll wrap it up with composite functions. If you master these key concepts, scoring full marks on this topic becomes very achievable. So let's get started and make sure you're ready to ace this section. Okay, what is a function? A function is an operation or a set of values. So a function, let's write it down. Function. A function is an operation or a set of operations that we apply to an input value to produce an output value. Okay, so let's first begin with the notation of functions. So sometimes we write functions like this. Now it means that f is the function that maps x onto 3x plus 2. Okay, this is how we literally read this. F is a function that maps x onto 3x plus 2. So basically, what are the set of operations? You're multiplying x with 3 and then adding 2. So your input value is x, then you multiply it with 3, add 2, and get an output value. Okay, this is what the definition says, and this is the function notation. But it is more commonly written as f of x is equals to 3x plus 2. It's exactly the same thing. Okay, so we read this as f of x is equals to 3x plus 2. Okay, so basically what is happening? So you get an input value, for example, x is equals to 1. Then what happens is that we perform a set of operations represented by the function and we get an output value. So if x is equals to 1, what are we going to do? This basically means the value of the function when x is equals to 1. So 3, when x is equals to 1, we're going to substitute 1 in place of x. And 2, what do we get? We get 3 plus 2, 5. Okay, this is our output. So this is the input. You input 1. So you might remember that, in earlier classes, this was represented as the function machine. So you input something into the function machine and it performs a couple of operations and then you receive an output value. Okay, so to find the value of a function, substitute the number or expression in the bracket for x in the formula. Okay, let's do a couple of examples here. If for f of 2, we're going to substitute 2 in place of x in the function. So we will get 3, 6, 7, 8. Okay, so if we have 2 as input, the function will give you 8 as the output. If to find f of 3, it means that we are going to substitute 3 in place of x to find the value of the function. So 3 into 3 plus 2, 9, 11. Okay, so all of these are the input values. These are the output values. Input values are basically the x values. Output value is the value of the function, is what we usually denote by y. The input values are the domain of the function. The output values are known as the range of the function. We're going to touch upon this in a bit. Before that, I want to make sure that you understand how we're going to use functions. Okay, so for example, if f of x is equals to 3x plus 2, as you've stated already, and the question asks you to find f of 7, what does it mean? It means the value of the function when x is equals to 7. Okay, so we're simply going to substitute. So you can just highlight wherever there is an x in the function and you're going to substitute this value there. So 3 into 7 plus 2, 21 plus 2 gives you 23. Okay, now for example, if we have f of 2x, what are you going to do? You're going to, so this is the name of the function. Okay, it tells you, because sometimes you might have more than one function in the question. So let's do this. G of x is equals to 2x minus 1. H of x is equals to 2 raised to the power x. Okay, so you have a couple of functions in the question. Now, how you're going to read this is that this is the name of the function. Okay, so this is going to tell you that you have to go to function f, and then in place of x, what are you going to substitute? You're going to substitute this. Okay, so just highlight x here and this. So wherever there's an x in the function, we are going to substitute 2x in its place. So 2x plus 2, you have 6x plus 2. This is your answer. Okay. Now, for example, they ask you to find g of 7x plus x squared. What are you going to do? You're going to go to function. This tells you the function that you're going to go and read. So it's going to be function g. And in place of x, what are you going to substitute? 7x plus x squared. So let's highlight all the x's that we have in the function. So in place of x, what are we going to substitute? We're going to substitute this expression. So it's going to be 2 into the expression 7x plus x squared minus 1. And then we're just going to simplify it. 14x plus 2x squared minus 1. Okay, so whatever is in the bracket is what you're going to substitute in the respective function in place of x. Okay, no matter what it is. So if they ask you to find h of what, a cat, you're simply going to go to function h, and wherever there is an x, you're going to replace it with whatever is, obviously they're not going to ask you to substitute a cat, but this is just an example to tell you that whatever is in the bracket is going to be substituted in the function in place of x. Okay, I hope this is clear. Now they can also give you the value of the function, and ask you to find the value of x. So for example, if g of x is equals to 2x minus 1, and they tell you that find the value of x for which g of x is equals to 11. So we need to find x for which g of x is equals to 11. Now, what is g of x? This is g of x, right? And g of x is equals to 11. So we're just going to substitute this expression here. So what are we going to get? 2x minus 1 is equals to 11. And now we have one equation with one unknown. We can simply solve it. 2x is equals to 11 plus 1. 2x is equals to 12. X is equals to 6. Right? Okay, let's do another part. If they tell you that g of x is equals to x plus 7, we're going to follow exactly the same thing. This is g of x, right? And g of x is equals to 2x minus 1. So we're just going to substitute this expression in place of g of x. So 2x minus 1 is equals to x plus 7. Let's solve for x. Okay, so when you're given the value of a function and you want to find the value of x, put the formula for the function equal to the number or the expression, whatever it is, and then solve the equation to find the value of x. These are pretty straightforward questions, and sometimes you can score 1 or 2 marks very easily by utilizing these very easy techniques. Okay, now we are going to move on to the domain and range of a function. So, for example, f of x is equals to x squared minus 3. As already explained, you will have a set of input values, and it is going to map those input values by performing a couple of operations into output values. Okay, so what are the input values? Input values are basically the x values. So 1, 2, 3. If you substitute 1 into the function, you get 1 squared minus 3, which is negative 2. So this is the output. And this is the function operation that has been performed on the input value. If you substitute 2 into the function, you get negative 1. Sorry, positive 1. 4 minus 3 is positive 1. And if you substitute 3, you're going to get 6. Okay, so these input or the x values are known as the domain of the function, while the output or y values, x values or y values, they're known as the range of the function. Okay, so the set of input values for a function, while the range is the set of output values for a function. Okay, now let's do a couple of practice questions as to how a question about domain and range can appear in your exams. Okay, so let's do an example. So function f of x is equals to x squared minus 2x, And they're asking you to find the range for this function if the domain is x is equals to 1, 2, 3, 4a. So this is a pretty straightforward and simple question because they've they've stated your domain distinctly. So there are 4 elements in your set. The domain consists of 1, 2, 3, and 4a. These are your input values. Now all you have to do is find the respective y values or the output values, and that is going to be your range. Okay, so f of 1. You're going to go to function f and substitute 1 in place of x. Wherever there's an x, we're going to replace it with 1. So 1 square minus 2 into 1. 1 minus 2 is minus 1. Okay. Next, we have to find f of 2. 2 square minus 2 into 2 is 4 minus 4, which is 0. F of 3 is 3 square minus 2 into 3. 9 minus 6, so it is 3. And last is f of 4a. Simply go to the function f and substitute 4a in place of x. So 4a square minus 2 into 4a is going to give you 16a square minus 8a. Okay, so this green highlighted set or numbers or elements in the set comprise or make up your domain, and the respective y values or output is what your range is going to be made up of. Okay, so the answer to this question is range of x is equals to -1, 0, 3, and 16a square minus 8a. Okay, so f of x is equals to -1, 0, 3, 16a square minus 8a. So this is your answer. This is the range of the function. However, what happens when rather than separately stating the elements of domain, they give you a continuous interval for domain. Let's practice one question. So a function g is defined by g of x is equals to 3 minus 2x. Find the range corresponding to the domain -1, x is greater than or equal to -1 and less than or equal to 2. Okay, so see here they've given us a continuous interval. Whenever this is the case that you have a continuous interval, it is my recommendation to sketch the graph. Okay, that is going to eliminate any chances of errors that you might make. Now for sketching graphs, I hope that you've had a chance to look at my videos. This is the video for sketching graphs, and I would also recommend that you need to have a look at the video explaining the asymptotes. Okay, because asymptotes are the lines, invisible or imaginary lines, which the function never crosses or touches, because at that x point or that y point, the function becomes undefined. So what does that mean? That means that if the function is undefined at a certain value of x, then that x value cannot be part of the domain. Okay, we'll touch upon this later. But in order to ensure that you know how to sketch different functions, please have a look at these videos. Okay, so now see. First, you need to understand what function is this. Since the power of x is 1, it is a linear function. What is a linear function? It is a straight line graph. Okay, so we're going to quickly sketch it. G of x is equals to 3 minus 2x. So how do we sketch a linear function, or any function for that matter? We first find the intercepts. Okay, so to find the y-intercept, we're going to plug x is equals to 0 in the function, and we get y is equals to 3 minus 2 into 0. So y or g of x, it's the same thing, okay? It is equal to 3, okay? So this is the y-axis, this is the x-axis. So it crosses the y-axis at 3. Now let's substitute y is equals to 0 or g of x equals to 0 to find the x-intercepts. So 3 minus 2x is equals to 0. X is equals to x is equals to 3 over 2, right, which is 1.5. So it is going to cross the x-axis somewhere at 1.5. Okay, let's draw the line. You just need 2 points to sketch a straight line. In this case, the intercepts are going to be sufficient. Okay, so this is our line. Now, what is the question asking us? We need to find the range. Range is basically the set of y values corresponding to the domain -1 and 2. Okay, so where is -1? -1, and this is 2. So according to the question, this is our domain, and for this domain, we need to find the respective range. Okay, so what are we going to do? We're going to substitute -1 into the function, and we're going to find the respective y value. Okay, so if x is equals to -1, our function is going to produce, this is 5. Okay, so this is going to be 5. This is 5. And when function is x is equals to 2, the function gives us -1. Okay, so this is going to be -1. Sorry, your 2 should be, okay, this doesn't make sense. I'm sorry. This is the value for 3. Your 2 is going to be here somewhere. Okay, so for 2, the respective y value is -1. Okay, so now if you know, you can make sense graphically. These are your x values. So the maximum value is at -1. So your function is 5. Then for x is equals to 0, it's going to be 3. and then it's going to keep getting low until 2, where it is the lowest, -1. Okay, so even though the function has a lower value after 2, but all these points are not part of the domain. Similarly, for bigger negative values, the function is going to have even larger y values, but it is not um, the domain does not include bigger negative numbers. So your domain is greater than or equal to -1, and then it is less than or equal to 2. Anything out of this domain is not our concern as far as this question or this part is concerned. Okay, so we want to see that for this domain, what are the possible y values that we can get. So -1 is going to give you the maximum value, which is 5, and 2 is going to give you the minimum value, which is -1. So the function is going to range between -1 and 5 for this domain. Okay, so your answer is going to be, the range is -1 and 5. These are going to be inclusive inequalities. Why? Because the domain is also inclusive. Okay. That, it's very simple. We can just simply substitute one end of the inequality and the other end, and whatever you get will formulate the range of the function. It's easier for straight line graphs. In the next part, we're going to do a quadratic function, and then you'll see how it can be misleading at times. Okay, but before we move on to that, let's solve the second part of this question. So you need to find the domain of G corresponding to the range g of x is greater than or equal to 3 and less than or equal to 2. Okay, so our function was 3 minus 2x. We'd already sketched it. I'm quickly going to resketch it. This is 3, this is 1.5. Okay. 1.5, 3. Now the question is asking you to find the domain, the range of x values for what? If your range is between -3 and 2. Okay, where is -3 now? Here, -3 and 2. Okay, so this is your range, and for this range you need to find the respective domain. Okay, so what are we going to do? We're going to substitute the value of function to 2 and find the x value, which we're going to get here. This is going to be x1, and then we're going to substitute 3 as the function value and find the respective y value, x value, sorry. So it's going to be this value, x2. Okay, so what is your range domain going to be? This, between x1 and x2. Okay, so let's quickly do that. So if g of x is equals to 2, x is 1/2, and if g of x is equals to -3, x is 3. So what is your domain going to be? The domain is going to be this. X is greater than or equal to 1/2 and less than or equal to 3. Okay, so for this range, what are we going to do? We're going to find the x value at 2 and then x value at 3, and then this is going to be your domain, the respective domain for this range. Okay, and again the inequalities are inclusive because the range was inclusive. Now this is a pretty straightforward question where if you simply substitute the upper and lower bounds of the range or domain, you would get the respective domain or range depending on what the question is asking you. Now let's do an example where it's not that simple. Okay, so let's say that a function h is defined by h of x is equals to x squared minus 4x plus 5, and the question is asking you to find the range corresponding to the domain of x greater than or equal to 1 and less than 4. Okay, make notice of the fact that this is an inclusive inequality and this is a strict inequality. Okay. The second thing that you need to notice is that what is this function? Since the maximum power of x is 2, it is a quadratic function. And I'm assuming that you've seen the video on sketching of different functions. So a quadratic function can have a U-shaped parabola or an inverted U-shaped parabola. It depends on the coefficient of x squared. Since the coefficient of x squared in this particular case is positive, this is the shape that we can expect, a U-shaped parabola. U-shaped parabola. Okay. Now, what do we need? We need a turning point and we need the intercepts to sketch the graph. To find the turning point, what do? Express this quadratic function in completed square form. Assuming that all of you know how to do that, I'm not going to get into details, but what is the square that you're going to add and subtract from the expression? You're mentally going to divide the coefficient of x by 2, and whatever you get is going to be the square that you're going to add and subtract. So now this can be factorized and written as x minus 2 whole square minus 4 plus 5 is plus 1. So this is the completed square form. Again, I hope all of you know that the turning point is going to be this. The x coordinate is going to be this value with the opposite sign, and the y coordinate is going to be this value with the same sign. So what is the turning point? 2, because it has a negative 2, we're going to change signs, and positive 1. So 2, 1 is the turning point of your graph. Let's find the intercept, y-intercept. To find the y-intercept, you're just simply going to substitute x is equals to 0 in the function. So 0 square minus 4 into 0 plus 5 is going to give you 5. Let's sketch the graph very quickly. Okay. This is y-axis, this is x-axis. 2, 1 is the turning point. 5 is the y-intercept. Okay, and we know that our graph is going to be something like this. So it's going to cross the y-axis at 5 and it's going to turn at 2, 1. Okay, so make a couple of hand sketches before actually using the pencil to sketch. Okay, so that way you'll be able to make a better fit on your graph. Okay, so this is the turning point, crosses at 5, Okay, so your graph is going to be something like this. Okay, now what's the question? Once you've sketched the graph, okay, sorry, for the previous graph as well, please remember to label your line. Okay, we're also going to label our graph, which is x squared minus 4x plus 5. Okay, now the question says that we need to find the range, so we need to find the set of y values corresponding to the domain x is greater than or equal to 1 and less than 4. Okay, so what are the x values? 1 is included and 4, which is not included. But at x is equals to 1, this is the value that you're going to get. Okay, and for y is equals to, x is equals to 4, 16 minus 16 is 5. Okay, so this is your value for the function. Wait, to simply change it a little. Wait. Okay, yes. Okay, so at x is equals to 4, this is your y2. So previously what we had done was that, we would assume that your range is going to be between y1 and y2 for this domain. However, let's have a look at the graph. Okay, this is the domain. What are the values of the function for this domain? So we begin at y1 and see it decreases first and then it starts increasing. Okay, so what is the minimum value of the range for this domain? So this is the minimum value. Okay, so our range is going to be between this value and y2, the maximum value. Okay, and this is the minimum, this is the turning point, so this is going to be the minimum value, which is basically 1. Okay, so what is the value? It is 1. So what is the range going to be? The range is going to be h of x is going to be greater than or equal to 1, but less than 5. Why less than 5? Because 4 is not included. It is less than. So the y value is also going to be less than. 4 and 5 is not included in the range. Okay. Now the point that I want you to understand here is that had we simply substituted the upper and lower bounds of the domain, we would have gotten the incorrect answer. Okay, we would have gotten this value of y1 and the upper bound would have been correct. So, it's best to quickly sketch the graph and then visually see the corresponding domain for a given range or given a corresponding domain for a given range. Okay, whatever the question is asking you, it is best to sketch and then decide. In this case, the function reaches an even lower value than what you get for the lower bound of the domain. Okay, so I hope this is clear. If it isn't, please rewatch this section, and if you still have any confusions, feel free to drop in a comment and I will try and get back to you. Another thing that I want you to keep in mind is that, for example, if f of x is fx minus 3 over x minus 4, and they ask you to state the value of x, which cannot belong to the domain. So see, the value we've discussed, this is a reciprocal function, and we've discussed that division by 0 is not possible, right? So if the denominator is equal to 0, what happens? Your function becomes undefined. So what is the denominator? X minus 4, if that is equal to 0, which means if x is equals to 4, the function will be undefined. So the domain cannot have x is equals to 4 in it, right? Because if x is equals to 4, the denominator becomes 0, division by 0 is not possible. Okay, so please keep this point in mind as well. So I think we've covered domain and range in a lot of detail. In case of any problems, please drop in a comment and inshallah I will get back to you as soon as I can. Let's move on to the next section, which is finding the inverse of a function. The function f of x maps input values to output values, right? So let's quickly visually represent this. So these are your input values, and the function f of x is mapping them onto the output values. So this is your input and this is the output. What is the inverse function doing? The function that maps these output values back to the same input values is called the inverse function. Okay, so see. So what is happening here? These are the output values and they're being mapped onto the same input values by what function? The inverse function. The inverse function is written like this. It is denoted by f raised to the power negative 1, but you never read it like that. You always read it as f inverse of x. Okay? So this is the inverse function and this is your normal function. What is an inverse function? An inverse function has exactly the opposite effect of that of a given function. Okay? So what it basically does is that the inverse function maps the output values back to the same input values. The inverse function maps the output values back to the same input values. Okay, what it means is that, if f of x maps x onto y, the inverse function, which is f inverse of x, maps y back onto x. Okay, now let's do a couple of examples to understand how we are going to find the inverse function. So what are the steps to find inverse? So to find the formula of an inverse function, you need to put y in place of f of x. Put y in place of f of x. Then you're going to rearrange the formula to make x the subject. Okay, you have to make x the subject. And finally, you need to replace y with x replace y with x and x with f inverse x. So this might not make sense to you right now, but I'm going to do a couple of examples and then it's going to be super clear. Okay, so let's do an example right below this. So two functions, f of x is equals to 2x over 3 minus 7 and g of x is equals to 8 over x minus 2 plus 1. So these are the two functions which are defined. You need to find, so find the inverse function f inverse x and evaluate f inverse 11. Okay, so it's not a pretty, a very simple example. I've kept the functions to be slightly complicated. Okay, so what is the first step? The first step is that you need to put y in place of f of x. So step 1, y in place of f of x would give you 2x over 3 minus 7. Okay, so what is step 1? We've simply replaced f of x with y, and the rest is exactly the same. Now you need to make x the subject. Okay, so let's make x the subject. We take negative 7 to the other side, it becomes positive. Then we're going to take 3, which is in the denominator, to the other side. So 3 into y plus 7 is equals to 2x. And now, since we need to make x the subject, we're simply going to take 2 to the other side. It is being multiplied here with x. It will be divided on the other side. So x is equals to 3y plus 21 divided by 2. Okay, so what is the inverse function? The inverse function is 3y plus 21. No, it's not the inverse function. We're on step 2. Now what are we going to do? We need to replace y with x. And what is the second replacement? We need to replace x with f inverse x. Okay, so what are we going to do? Going to replace x with f inverse x and y with x. So what do we have? We have f inverse of x is equals to 3x plus 21 over 2. So we have successfully done the first part of our problem. What are they asking you in the second part? We need to find f inverse of 11. So we're simply going to do follow the same steps that we've learned. This tells you the name of the function. So we're going to the function f inverse. And what are we going to replace x with? 11. So wherever there's x in the function, it is going to be replaced by 11. So f inverse of 11 is 3 into 11 plus 21 over 2. What is it? 33 plus 21 is going to be 454 divided by 2. So what do I have? I have 27 as the answer. Okay, so if you just memorize these steps, it becomes pretty straightforward and simple to find the inverse. Okay, let's copy this onto our next page. Okay, here it is. Now, what is the second part of the question? So it states that g of x is equals to 8 over x minus 2 plus 1. Part B of the question is that find the inverse function, g inverse of x, and find a if g inverse of a is equals to 6. Okay, so what is the first step? We need to find g inverse of x. For that, we are going to follow the steps. Which steps? These steps. Step 1, replace y in place of the function f of x, because it is g of x here. We're simply going to replace g of x with y. Second step, make x the subject. So y minus 1 is equals to 8 over x minus 2. What are we going to do next? We are simply going to take this denominator here to the other side, so it will be multiplied with y minus 1. And now we're going to pick this bracket and take it to the other side. It is being multiplied here, so it will be divided when taken to the other side. So x minus 2 is equals to 8 divided by y minus 1. We're going to pick this negative 2 now and take it to the other side where it's going to become positive. Okay, so we are done with step 2 and we've successfully made x the subject. What is the next last step? We're going to make replacements. So x is going to be replaced with the inverse function. So g inverse x is equals to 8 over y minus 1. We need to replace y with x. So x minus 1 plus 2. So we have successfully evaluated the inverse function for g of x. Okay, now in the second part, they're telling us that g inverse of a is equals to 6 and we need to find the value of a. So this is the name of the function where is g inverse, here it is, and we're going to replace x with a. So wherever there is x in the equation, in the function, we're going to replace it with a. So what do we have? And g inverse of a is equal to 6. So this is going to be equal to 6, okay? So g inverse of a is going to be 8 over, we're replacing x with a minus 1 plus 2. What is the value of g inverse of a? It is 6. So we're going to substitute 6 here. So 6 is equals to 8 over a minus 1 plus 2. Let's take 2 to the other side. 6 minus 2 is 4. Is equals to 8 over a minus 1. We're going to take this denominator to the other side and multiply it with 4. 4a minus 4 is equals to 8. 4a is equals to 12. A is equals to 3. So what is the value of a? The value of a is equals to 3. So this is how you find the inverse. In general, always remember that if f of x is equals to y, f inverse of y will be equal to x. Okay? We know that y is equals to f of x. Then you should also know that x is equals to f inverse of y. Let's do an example very quickly to make sure that there are no confusions regarding finding inverses. So for example, if p of x is equals to 2 over x minus 2 and q of x is equals to x plus 2 over 2, and the question asks you to solve 2 times p inverse of x is equals to 3 times q inverse of x. So what are you going to do here? To solve this equation, you first need to find the inverse function of p and the inverse function of q. So we're quickly going to do that. We're going to replace p of x with y. We're going to make x the subject. Plus 2. And we're going to make replacements. So p inverse of x is equals to 2 over x plus 2. So what have we done? We first replaced the function with y, first step. Then we manipulated the equation such that x is the subject, step 2. And then we made replacement. Y was replaced with x was replaced with the inverse function. Okay, so this was p inverse x. Let's now find q inverse. So we're going to replace q of x with y. Let's make x the subject. Okay, so x is now the subject, which is, let's just write it the other way around. It's exactly the same thing. Let's make replacements. Q inverse x is equals to 2x minus 2. So what have we done? We replaced q of x with y, step 1. Then we manipulated the equation such that x is the subject, step 2. And then we made replacements. X was replaced with the inverse function, y was replaced with x. So now we have both the inverse functions. What are we going to do? We are going to make substitutions. So in place of p inverse of x, we are going to substitute this. And in place of q inverse x, we are going to substitute the value of q inverse x. Let's write it down. So 2 times, what is p inverse of x? 2 over x plus 2 is equals to 3 times, okay, wait. 3 times 2x minus 2. Okay, so this is basically this, right? So 2 times p inverse of x and 3 times q inverse x. The value of q inverse x is 2x minus 2. So this now all you have to do is solve this equation. So 4 over x plus 4 is equals to 6x minus 6. 4 plus 4x over x, 6x minus 6. Let's take, we took the LCM so that, multiply it with x. Let's take x to the other side. So 4 plus 4x is equals to 6x squared minus 6x. 6x squared minus 6x minus 4x minus 4 is equals to 0. So what do we have? We have 6x squared minus 10x minus 4 is equals to 0. So 6 into 4 is 24. Middle term breaking. 6x squared. We need negative 24 and negative 10. Okay, so what are the possible factors that you can have? 1 and 24, 2 and 12. Okay, so negative 12x plus 2x minus 4 is equals to 0. Let's take 6x common. X minus 2. Let's take 2 common. X minus 2. 6x plus 2. X minus 2 is equals to 0. So x is equals to negative 1 over 3 or 2. Okay. So I hope you have no problems in solving this question. Finding inverse was the only thing that you had to, be an expert of to solve this question. But not only that, sorry, you also need to know how to make a variable the subject of the equation. Here you also needed to know how to solve quadratic equation through factorization. So, a lot of things for math, it's not just one topic. Everything is interlinked. Okay? So you need to have strong math skills and basics in order to solve most of the paper. Now on to the last part of our video, composite functions. What are composite functions? When two or more functions are combined, the result is called a composite function. So the composite function of two functions, f of x and g of x, is written as f of g of x. Okay, this is exactly the same as f of g of x. Okay, so you can very easily place brackets here. It's going to make your life easy. Okay, and also in general, you need to keep in mind that f of g of x is usually not equal to g of f of x. Sometimes in very special cases they are equal, but in general most of the time they're not equal. Okay, and the order of the functions is also very important. Now let's practice a couple of questions to understand how we can find composite functions. So let's imagine that we have a function f of x is equals to 2x minus 5 and g of x is equals to x squared minus 3x. You need to find a simplified expression for the composite function f of g of x. Okay, what are we going to do? We are going to place brackets here. Okay, and what is g of x? Go to function g and then c. So this is g of x, right? So we're simply going to make the substitution. So what do we have? F of x squared minus 3x. Okay, understand. So f of g of x is in brackets. This is g of x. What is the value of g of x? It is x squared minus 3x. So we're simply substituted that here. And now it is just like a simple function question where we're making substitution. So what are you going to do? You're going to read the name of the function. It is function f. You're going to go to function f. And in place of x, what are you going to substitute? X squared minus 3x. Whatever is in the bracket. So wherever there's x in the function, we're going to make this substitution. So 2, in place of x, we're going to make the substitution x squared minus 3x minus 5. So what do we have? 2x squared minus 6x minus 5. Okay, so this is the answer. This is f of g of x. What is part B? Okay, what if they ask us to find f of x? This can also be written as f square x. Okay? Okay. What are we going to do? We are going to place the brackets. What is the value of f of x? It is 2x minus 5, right? F of x is equals to 2x minus 5. So we are going to make this replacement here. F into 2x minus 5. It becomes a simple function now. You're going to go to function f, and in place of x, you're going to substitute 2x minus 5. So wherever there's x in the function, so 2 into x, we're going to make the replacement minus 5. What is the replacement? 2x minus 5. So 4x minus 10 minus 5, 4x minus 15. So f of x is equals to 4x minus 15. Okay, let's have a look at part C. So find the value of g of f of 3. Okay, so let's write down the functions first. F of x is equals to 2x minus 5. G of x was x squared minus 3x. Okay, so we need to find g of f of 3. We're first going to place our brackets. What is f of 3? We first need to find f of 3. How are we going to do that? We're going to go to function f and substitute 3 in place of x. So 2 into 3 minus 5. 2 into 3 minus 5 is 6 minus 5 is 1. Okay, so what is f of 3? F of 3 is equals to 1. We're going to make this substitution here. So f of 3 is 1, so g of 1. That is what you have to find. Now you're going to go to function g, which is here, and in place of x we're going to substitute 1. So wherever we have x in the function, that will be replaced by 1. Okay, so 1 square minus 3 into 1 is 1 minus 3, negative 2. Okay, so g of f of 3 is equals to negative 2. I hope this is clear. Composite functions are not very technical. All you have to do is understand how to make substitutions. Okay, we're going to do one last question in order to ensure that you understand composite functions, inverse functions, and functions in general completely. Okay, so two functions, p of x is equals to x plus 2 over 4, and q of x is equals to 3x minus 7. Find the function p q inverse x. Okay, we'll do the second part later. So we know that two functions are in question. So this is a composite function. Let's place our brackets. So what do we need first? We need this function q inverse of x. Now where is q of x? Q of x is 3x minus 7. We need to find the inverse function. We're going to equate it to y, then make x the subject. Okay, and then we're going to make our replacements. Replace x with the inverse function. Replace y with x. So this is the inverse function of q. Okay, and we're going to substitute it in here. So p into, let's make the replacement, x plus 7 over 3. What are we going to do now? Where is function p? This is function p, okay? And we're going to replace x with whatever is in the bracket here. Okay, so wherever there's x in the function, we are going to replace it with x plus 7 over 3. So what do we have? X plus 7 over 3 plus 2 divided by 4. Okay, so what do we get? X plus 7 over 12 plus 2 over 4. Let's make the denominator same, x plus 7 plus 6 over 12. So what do we have? We have x plus 13 over 12. So p q inverse x is this. This is your answer. Okay. So to find this composite function, you first had to find the inverse of q. So after doing that, we made the replacements and just simplified the equation, and we have our final answer here. Okay, the second part of the question states, solve the equation PQ inverse x minus QQX is equals to 7/3. Okay, so we've evaluated this part of the equation in the previous part. Here, we're simply going to write that down. So PQ inverse x is equals to x plus 13/12. Now we need this part of the equation. So to find QQX, we're going to place brackets. What is function QX? It's 3x minus 7. So we're going to replace this with 3x minus 7. So what do we have? Q of 3x minus 7. What is function Q? It is 3x minus 7. So what are we going to do now? We're going to go to function Q and replace the x with, we're going to replace the x with 3x minus 7. Okay, so what do we have? 3 into x की जगह क्या आएगा? 3x minus 7 minus 7. So 9x minus 21 minus 7 gives you 9x minus 28. Okay, so now we also have this part. QQX is equals to 9x minus 28. Let's make the substitutions into the function. Okay, PQ inverse is this. Let's make this. So in place of the yellow highlighted function, we're going to write x plus 13/12 minus, what is QQX? 9x minus 28. That is equal to 7/3. Make sure that you place these brackets because you have a negative sign. When you're going to open the bracket, it's going to become positive. Okay, so let's solve the function. So x plus 13/12 minus 9x plus 28 is equals to 7/3. We're going to make the denominators common. So we're going to have x plus 13 minus 336. No, 12 into 9. What's going to multiply this with 12, right? Okay, so let's make multiply. It's going to become 108x plus 336 is equals to 7/3/12. So what are we going to do? We're going to take this 12 to the other side. It will be multiplied. So here it comes. What do we have now? So 28. So what do we have? We have x plus 13 minus 108x plus 336 is equals to 28. Let's take 28 to this side. And what do we have? X plus 13 minus 108x plus 336 minus 28 is equals to 0. Let's simplify the like terms. X minus 108x would be negative 107x plus 336 minus 28 is going to be plus 321 is equals to 0. x is equals to negative 321 divided by negative 107. Okay, and using the calculator, you can find that x is equals to 3. Okay, so even though the working was a bit tedious, the function concepts were not very difficult. All you had to do was always remember that for composite functions, you need to place brackets and then just make the substitutions and go with the flow. No matter how difficult or different your working may seem, just continue doing that, continue simplifying the expressions, and inshallah, you will be able to get to the right answer. Okay? And that's a wrap on functions. Remember, with a little practice, mastering this topic is completely within your reach. Every question that you solve builds your confidence, and every concept you understand takes you one step closer to your goals. Keep pushing yourself, you're capable of achieving A stars and so much more. And if you found this video helpful, don't forget to like, subscribe, and share it with your friends who might need it too. Stay consistent, stay confident, and as always, keep making math remathable. See you in the next one.